So now we're going to take the exposure function that we developed, the approach that we developed in the previous example, and apply it to the advertising selection. Okay, so now we use the same basic data as from chapter 4, except that now instead of the exposures being just a constant number multiplied by the number of advertisements that we run, it's going to be an exponential function like what we saw in the previous example. So here, for each combination of advertisement that we're going to run on a given show and a demographic group, so we're going to have an A and a B, and we will use the A times 1 minus e to the power of minus bn as our function for exposures. Okay, so we're going to assume that this A and B are already developed now. We saw the example of how to develop it in the previous example. So let's assume that it's all done for all the combinations and the A and the B values are given, and we're going to use it in that kind of function to develop the exposures. So let's go to the Excel file. So here we are given for each television show and each demographic group. This first table gives us the constant, which is our A. Okay. The second table gives us B, the second coefficient needed for determining the exposures. So this is the cost per ad that is given. Okay, and number of ads we have to purchase, that's our changing cell. Okay. And the exposure we're going to receive in each combination, so we're going to use that function we saw previously. So that's what the exposure is going to be like. So we're going to assume that the exposure will be like that. Okay, so here dot width, so it's going to be A times 1 minus exp within brackets minus B times the number of ads we're going to run. Now this has to be absolute reference properly. So when you copy for different columns must change, but the rows should remain the same. So row should be 25. So close parenthesis and one more parenthesis. Okay, so that gives us the number of exposures we will have for that. So now we copy like this and copy like that. So the actual exposures will then be sum of each row. Okay. Sum like that. Now these are the required exposures. And the actual exposures must be greater than or equal to required exposures. So now let's give some names. Cost, number of ads, okay, and actual exposures, required exposures. The total cost is then some product of cost per ad and the number of ads we're going to run. And that's, let's give a name. And that's our objective function. So let's color code that. Alright, so now we can run solver. Now that's total cost, so we want to minimize that. And changing cell will be that. Okay, and constraint will be actual exposures greater than or equal to required exposures. Okay, let's make sure that we have multi-start required bounds variable, solve, and we have a solution. Okay, so now we can run a solve a table if we require more exposures or less exposures, and for that we have to make some modification to this model, which we will do next. Now we want to modify this model so that we can run a solver table. So let's first copy that over here, and we'll call this original required. Okay. Now we'll remove this. Okay, we'll go and clear it. Okay. Now we'll add an additional cell here, and we'll call that percent increase in exposure. So we'll first initially set that up as 0%. So that's a input. So, okay, let's give a name. Now required exposures then is original required multiplied by 1 plus the percentage increase. So that way when it is 0, the required exposure is the same as the original. Okay. Now this is still, the name is required exposures. Okay, so let's give a name for this one. Oh, this we have already given a name. Okay, so now let's run solver. Make sure that solver runs. Okay, so since this is 0, we get the same answer like before. So now we want to run solver table, and we'll go from minus 20% in increments of 10% to 50%. So percent increase, get minus 20%. Remember, 20%, the number value is minus 0.2, and maximum is 0.5, 50%, and we will go in increments of 10%, which is 0.1. Then output cell, we'll just look at the cost. So here is the plot.